Alright, chapter 5.5 is taking the roots of real numbers. Now, up until now, in Algebra 1, you've been doing a lot of square roots. In fact, that's the only thing you've been doing is square roots. And so what you've got to understand is that taking square roots is taking the second root of a number. So, give you guys an example. If I take the square root of 4, that gives me 2, and that's because 2 squared equals 4, right? There's this 2 squared out here. Just like the square root of 9 is equal to 3, and that's because 3 squared equals 9. Okay? Now, what we're going to do now is, ta-da, higher roots. We're going to take third, fourth, and fifth roots of numbers. For example, if I take the cube root of 27, now keep in mind this 3 out here indicates cube root. Cube root of 27 is 3, and that is because 3 to the third power equals 27. If I take the fourth root of 256, that is going to give me 4, and that is because 4 to the fourth power, right, the powers are going to match, equals 256. Okay, if I take the fifth root of 32, that's going to give me 2, and that's because 2 to the fifth power equals 32. All right, so when you see the small number hanging outside the exponent, that means that's the number root they're asking you to take for them. All right? Give me a second. I'm going to jot down a couple of notes for you guys. I'll be back in a second. Couple of rules. One is that odd numbers can produce negative numbers. And let me give you guys an example of this. If I take the fifth root of negative 32, that equals negative 2. And that is because negative 2 to the fifth power is equal to negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Well, I've got 32 here, but since I have, let's see, negative times negative is positive, times negative is negative, times negative is positive, times negative is negative. So odd numbers, or odd-powered roots, can produce negative numbers. So your 3s, your 5s, your 7s, seventh roots can produce negative numbers. Even roots cannot produce negative numbers. So if I take, say, and you guys know this, if I took the square root of negative 4, that doesn't give me no real answer. In a couple of chapters, we'll deal with what we call imaginary numbers, but that's a little too far ahead. We're not working at Chuck E. Cheese yet. No real answer. So if you take, say, the fourth root of, say, negative 16, it still produces no real answer. So keep that in mind. Let me get down another set of notes. Hold on. Okay, this is a really important rule here. It says when taking an even power of something, a variable, whatnot, if an odd power is produced, it must be placed in the absolute value to ensure that the answer is not negative. That's a lot of words, and I think an example might just help you out a little bit. If I say take the fourth root, we call this number 1, if I take the fourth root of, say, x to the fourth, what's going to happen is the 4's are going to cancel each other out. I am left with x. And actually, it's really x to the first power, right? So I had an even power. I took the even root of it. And actually, you know what? This should not be when taking an even power. This should be when taking an even root. Where was I? I took the even root of a number. I produced an odd power, which means that I need to place that odd power in absolute value, because I need to make sure that x was positive the whole time, because if x was negative, we would have had no real answer. So just keep that in mind. Okay, so make sure that any odd powers that result from an even root, you got to put them in absolute value. Sometimes the book's going to jump around about that, but just to be on the safe side, we'll always put them in absolute value. All right? Hang on. Having said that, I think it is time to just overload you with a bunch of examples, because that is sometimes the best way to learn. Actually, most of the time, I think that's the best way to learn. So I'm going to take the fourth root of this really large thing. This is 16 times x plus 3 quantity to the 12th power. All right, so what I'm going to do is I'm going to take each of these individually. The fourth root of 16 and then times the fourth root of x plus 3 to the 12th power. Well, the fourth root of 16, that's easy. That's 2. Well, the fourth root of x plus 3 to the 12th power, I'm going to take my exponent and I'm going to take my root and I'm going to divide them. What I get is 3, so I get total x plus 3 to the third power. Now remember, I have an odd power resulting, which means that I need to put my x plus 3 in absolute value bars to ensure that that answer was positive from the beginning. Number 3 here. If I take the fourth root of t to the 8th, that is, I'm going to take 8 and divide it by 4, I get t squared. Now, keep in mind, I do not need absolute values here, because regardless of whether it was positive or negative, once I square it, it's going to become positive. So there is no need for absolute values on that problem. Why don't we take the square root of, say, the quantity 5f squared. I'm sorry, not squared, to the fourth. Squared would have been too easy. Okay, remember, the square root is really the second root of this number, so I'm going to take 4 and divide it by 2. I end up with 5f squared. Even power being placed, so I don't need absolute value bars. Let's go ahead and simplify that. That is 25f squared. Number 5. Let's go with the square root again of 64x to the 6th power. Okay, the square root of 64 is 8. X to the 6th divided by 2 is x to the 3rd. Now remember, I've got an odd power resulting, so I'm going to put my x to the 3rd in absolute value bars. Number 6. The cube root of 8 b to the 3rd c to the 3rd. Well, the cube root of 8 is 2. The 3's are going to cancel each other out, so I end up with BC. Now, I'm taking the odd root of something, which means I do not need absolute values, because remember, odd roots can produce negative numbers, and it's not a big deal. 7. The square root of 3x plus y squared. Well, the square root and the square are going to cancel each other out, leaving me with 3x plus y, technically to the first power. Because I have an odd power resulting from an even root, that baby gets put in absolute value bars. Next, number 8. If I am going to take the square root of x squared plus 6x plus 9, I hope we have not forgotten our factoring, because what this really is this is really x plus 3 times x plus 3, which is really x plus 3 quantity squared. The square root and the square are going to cancel each other out, leaving me with x plus 3 to the first power, right? An odd power, which means I need to put it in absolute value bars. Next, the square root of 16 m squared minus 24mn plus 9m squared. That is really the square root of 4m minus 3n squared. Those are going to cancel each other out. I end up with the absolute value of 4m minus 3n. Okay, I think that is all I have for you on this lesson. See ya. Whoops.